Okay, for 17, this one's a little hard to fit on the whole screen, so I wanted to have it large enough so it's readable. We can scroll through all the questions and we'll come back to it. Okay, and looking at each part. So first of all, before we read the question, let's look at what we're trying to answer. Which measures of central tendency do not exist for this data set? So here's the question. Here's the answer, sort of, that you can always expect on these. When you have a set of numbers, you can always add them together, divide by how many there are. You will always have a mean. When you have a set of numbers, you can also always put them in order and find which number's in the middle. You will always have a median. But as we saw if you looked at the last example we did in 16, sometimes there's not a mode because a mode requires more than one value. You have to have at least two of the same value. So it's possible that we're not going to have a mode, but if we have at least two of the same values, we'll have a mode as well, and then that's when we'll select none of the measures. So we look over this, and all we're looking for is there a number that occurs more than once? You might have already spotted it, I don't know. Oh, here's a 53. Here's a bunch of 53s. Here's some 63s. So definitely, but there's only one set of numbers, 53, that occurs 3 times. So there is a mode. So the answer to this, it's a little tricky. It's sort of like a negative, negative. There are no measures that occur that do not exist. Everything exists. Okay. The next question, let's scroll up. Most of it, and see, we could have, I guess, we sort of could have seen that there's 8 here, so we could think of this as a mode, but they've got them in classes, so going from 40 to 60. Okay. Suppose that the measurement 88, the largest one, so that's nice, they've got them in order for us. I forgot that they did that, but 88, that measurement, the largest measure in the data set, were replaced by 94. That would make it larger. Which measures of central tendency would be affected by the change? Well, the mode's not going to get affected because that's the 53 will still be the mode, right? There's not an additional mode. That's not affected. The median won't be affected because the 88 being taken out and replaced by something else, 94, does not change where the center of the data is. It doesn't. There's the same number there. So the median doesn't change. However, it will change when you add these together. The sum will be different. It'll actually be a little bit larger, right? And so the mean will change. So on this question, the only thing that's going to change is the mean. And then we'll look for, so what's the next question as it comes up? Suppose that starting with the original data set, the largest measurement were removed. Which measures of central tendency would be changed from those of the original data set? Okay, so it's kind of similar to the last question, but just a little bit different. What we're doing is we're removing the largest piece, so this is being erased. So it will change the total when we add this together. We'll change the sum. And we're dividing by a smaller number as well because there's fewer items. So you could do the calculation, but you're right, it's going to change what the mean is. So the mean will get changed. We'll look real quickly. The mode is still 53. That usually will not get affected by just removing a data piece at the top or bottom, but it could if the top or bottom were the mode, but it doesn't. Okay, so it doesn't affect the mode. It might affect the median. Does it change where the middle is? So there was 24 originally, right? So what was the median? Half of 24 is 12, so if we come 12 spaces, so what I did for the median, 24 divided by 2, because we're finding the middle, it's going to be 12. So there'll be 12 on one side, 12 on the other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 here, 12 there. So the median originally was halfway between 49 and 53. And I'm not going to calculate it because I'm going to show you what happens when we take out, well, maybe we do. So the median should have been 49 plus 53 divided by 2. Or you could see that 49 to 53 is a distance of 4. Half of 4 is 2. Add 2 to 49, and you've got 51. 51 is halfway between these two. 51. Yes, I said the word 2, and that's what I wrote. 51. This is one of the things is testing. Just be careful the numbers you write. So that was the original median. The new median, because we got this out, now there's only 23. So take 23 divided by 2. You're going to 12.5. You're going to the not 12.5, 11.5. Sometimes I try to get too clever for myself. Which means you'll go to 11th and it will be the 12th. Okay, so the new median, we're going to come 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It'll actually be the 12th number. And notice that there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 here. So 11 on each side. 49 is your new. So the new will be 49. It is affected. Now, had the median been pushed up a little bit, removing 1 might not affect it. It could have gone from 53 to 53. So that's why with the median you just have to check it out. So median, yes. This does get changed. The mode, no. The mean, yes. I should have put yes there, because now I'm looking back. What does this mean? So the mean and the median both will change. But the mode will not. Okay, so let's clear that out. So there we go. And then there's one more question. And this is dealing with the describe the distribution as far as skewness. Now this one is roughly symmetrical. Goes up like a bell shape, so something like that. It's going to be roughly symmetrical. But let me explain the other two, because the ones you get on the test might be one of the others. So what does it mean, negatively skewed? What it means is that this is sort of what we would call a left skew. It means that there's outliers or a few values at the negative side. So that would be like this with a big chunk over here. So something like that. Positively skewed is a right skew, which means we get the lump, and then out here we get a few. Okay, some of us focus on the lump, but what we need to focus on is sort of the outlier section, the lower part. So this is what a positive skew looks like. That's what a negative skew looks like, just in case you run into one of those. And that will take us through this question, which, what are we? This must be 17, and then we'll move on to the next.